So, an exoplanet is a planet that is outside of our solar system. And an exoplanet will be anyone that orbits around a different star, if that's a star in our galaxy or in a different galaxy, or even something that doesn't orbit around a star that's kind of loose on its own, roaming about the galaxy. I've always had an interest in space and science and sci-fi as well. I'm already sort of very predisposed to find this kind of work interesting and engaging. But what really got me was a conversation I had with one of my collaborators, one of the astrophysicists I worked with, who showed me that he'd been studying a set of exoplanets that orbit around a star a few light years away. And he had turned the ratios by which they orbit around their stars into musical frequencies. So if one orbits twice as fast as the next one, it will make a note that's twice as high, an octave higher than the next one. And this is a really interesting way of forming like quite weird but quite beautiful sounding harmonies out of these exoplanets. And it led me to think, well, okay, so these planets are really, really inspiring. The things that we know about them are poetically inspiring. They are really hot, really cold, really dark, made out of lava, made out of ice, raining quartz, whatever it is. But there are also these properties that scientists are discovering that are quite mathematical that can also lead to some really interesting new musical directions. So there's both this exploration in terms of the sort of poetic aesthetic side of it and some really interesting sort of hardcore nuts and boltsy musical questions that I don't think have really been heard before with an orchestra. Initially, I'd been talking to lots of different scientists and doing lots of research into these really sort of fascinating exoplanets and what makes them tick and why they're so different to the Earth and anything we know. So I had this idea of lots of different movements maybe. So there's a movement for this kind of planet, this planet as well, and it's sort of quite regimented. And you can still hear a little bit of that in the piece today. But as it developed, what I really found was that none of my scientist colleagues, for example, none of them are working on their own. They're all working with each other and all their work influences each other. And the way that I write music as well, it took on a more sort of like tone poem-like form where you're sort of, it's all now in one movement and you're sort of going through, maybe visiting all these different places, but these different ideas that come from different exoplanets are being added to your sort of musical recipe and remembered later on. So you sort of build up this knowledge of different musics and ideas that intersect with one another. And a lot of the process actually was after writing some of the music that represented this bit or that bit or the other, was thinking, actually, what happens if you collide these or layer them in this way? So exomusic, I think, is a term that I've invented. I'm very pleased about this. Maybe it isn't, but maybe someone else has thought of it as well. But it's this idea that I had, while talking to lots of different people, which is, what qualities of music are contingent on us being humans living on Earth, and what qualities of music might be more universally applicable. Probably life can't exist on an exoplanet that's 10,000 degrees Celsius and is only, extremely close to its star. That's not a very habitable environment. There's probably no music on that planet. Equally, there's probably no music on a planet that is extremely cold and has no water or ice or whatever. So there are certain planets on which life could exist, and that gives us certain conditions like how sound propagates through the air, how many moons they have, and what effect that has on the day-night cycle, and what effect might a day-night cycle have on the kind of music you write. And that's a sort of cultural question. Obviously, this is all massive speculation from me, but there are certain things which will be the same no matter where you are in the universe. So if you times a frequency by 2, you will get an octave higher, and those sound waves do fit in each other in a way that doesn't change mathematically no matter where you are in the universe. So things like the harmonic series and things like what might instruments be made out of? Well, what do we make them out of here? We make them out of wood, metal, skin, strings. These are fairly likely to be the same. But then what if an alien civilization lives underwater instead of above ground? And how would they communicate with each other? Would they communicate with each other with speech like we do? Probably not. Or might they use clicks like a dolphin? Or might they use some other type of communication? And then finally, there are sort of more higher level questions like how do we actually organize our music rhythmically, metrically? And what is that contingent on? This is a huge area of debate with lots of scholars arguing about why we make music in the way that we do. But it's been really interesting reading about some theories about where our rhythmic cycles come from, for example, and thinking about, well, what if there was exomusic that had different kinds of rhythmic cycles that would feel very strange to us, but nonetheless has some form of logic or sense to it. The piece is, I guess, mostly intended to sound like nothing else on Earth. That was the idea. So it's supposed to sound off the bat like we are hearing maybe big monolithic sounds or clouds of sounds that are very unusual to us, or very strange logics, the strange ways of organizing the instruments and the rhythms. There's one moment which I think has some of the most interesting textures in the piece, which comes about halfway through, or maybe two-thirds of the way through. This is based on a specific planet that one of my collaborators studied. It's called WASP 17b. And my collaborator Hannah Wakeford, she showed that this planet is tidally locked, which means that one side of the planet always faces the star and one side never faces the star. So this side is very, very, very hot and this side is very, very, very cold. And there's a line around the planet at which it jumps from being very hot to very cold as you cross that threshold. And she also showed that this planet has clouds that are made out of quartz, so tiny little glass shards, and that these quartz clouds are whipping around this planet at thousands of miles an hour. So it's this incredible image, which is also astonishingly true. This is actually happening in the universe. So I had these ideas of sort of glassy, quartzy-like textures, but also going between high energy and low energy. And there's a point in the piece where the whole orchestra is going between extremely low energy playing, so playing the bow so slowly it doesn't even speak, or muting the strings of the piano and playing them so you just get this sort of icy cracking sound. And then everyone transitions from that towards very, very fast playing and hugely sort of resplendent sounds, and sort of going in between these two states while the music itself is changing. So my collaborator, Raymond Peer-Humbert in Oxford, he's a professor of astrophysics there, he studies what are called hydrogen-rich atmosphere ocean worlds, or Haitian worlds, as they're sometimes called as well. So in our world, we know what the difference is between the air and the ocean, don't we? But on a Haitian world, you might not know the difference. You could fall and you would just slowly become immersed in water without ever actually landing in water. So these Haitian worlds, because they don't have that distinction, they are really fascinating places. They're very liminal places. The more you move down in the atmosphere, the more sort of wet you imagine the world to be, the more watery. And that was really influential at the start of the piece, where I have these bell plates which you strike and then lower into water and raise out like this. So the percussionists are sort of hitting these instruments, and that changes their tuning. They go down in tune when they're in water, and then they go up when they come back out. And as they're playing these, all the rest of the orchestra are coming in with these very sort of vapor-like sounds, the sort of almost like condensing sounds in the air to sort of build up this orchestral texture. And the other thing that Ray discovered about Haitian worlds is that they are hugely prone to the greenhouse effect, which, as we probably know, heat gets trapped inside a planet and can't escape, and more heat enters the planet and it gets hotter and hotter and hotter. So the thing about water vapor is that apparently it's a very good greenhouse gas, which means it's hard for heat to get past water vapor. So as heat enters a Haitian world, the ocean evaporates, and it evaporates into water vapor, which thickens the atmosphere, the hydrogen-rich atmosphere, which makes it even harder for any heat to escape, which means it's a runaway greenhouse effect. It speeds up and up and up and up. And this is quite influential as well on the first 5 or 6 minutes of the piece, where as all these instruments are coming in, they're becoming more and more high energy and none of them leave. And so you eventually sort of build up this sort of bubbling mass of instruments in a kind of runaway orchestra greenhouse, I suppose. I am looking forward massively to the world premiere of Exoplanets with the LPO. It's going to be really, really exciting. Such fantastic players, and Edward Gardner, such an amazing conductor. I'm really looking forward to it.